I'm Anil Kumar. Welcome to my series on test papers. Now we have some questions related to trigonometric equations. These should be solved within the given interval as discussed. Then question number 11, we are given cosecant A in quadrant 2, cos B in quadrant 4. And we need to determine the value of sine of A minus 2B. Question 12 and 13 are to prove trigonometric identities involving double angles. Perfect. So I hope you got a copy of these questions now. Now let's continue. We'll have trigonometric equations to solve and some trigonometric identities to prove. Question number 7. Solve 1 plus sine 2x minus 2 cos x equals to 1 when x is between minus pi to pi. Now here, let's rewrite this. We have 1 plus sine 2x minus cos 2x equals to 1. So that 1 and 1 cancels. So we have sine 2x minus 2 cos x. You could write 1 minus 1, which is 0. Now sine 2x can be written as 2 sine x cos x. And we have 2 cos x here equals to 0. 2 cos x can be taken as common. So we get sine x minus 1 equals to 0. So that gives us two possible solutions. One is that 2 cos x equals to 0. And the other one is sine x equals to 1, then that will be 0. Okay? Now we have to work in the interval minus pi to pi. That is kind of important to understand. So if you sketch your graph for sine x, for example, so sine x is kind of this. So where from minus pi to plus pi, it is 1 at pi by 2, correct? As far as the cos x is concerned, this is sine x, right? So if you sketch cos x, you know cos x is 0 at pi by 2 plus minus pi by 2, correct? So you could sketch like this. Okay. So it is 0 at pi by 2 and at minus pi by 2. Correct? So these are the two values where cos x is equal to 0. So here we get the answer as x is equal to plus minus pi by 2, and here we get x equals to pi by 2. Correct? So our answer here is x equals to plus minus pi by 2. Correct? So that is how we are going to solve this question. Let's move on and take question number 8. We have 2 plus 2 sine square x minus equals to 3 minus cos x. This time we have to provide solution between 0 to 2 pi. Now, it is better to write sine square x as 1 minus cos square x and bring all the terms together. So we'll rewrite this as 2 plus 2 times 1 minus cos square x. Bringing 3 here because it's minus 3 plus cos x equals to 0. Right? So 2 minus 3 is minus 1, and let's open the bracket first and then we'll do. So you get 2 plus 2 minus 2 cos square x minus 3 plus cos x equals to 0. 2 plus 2 is 4. 4 minus 3 is 1. So now we can write this as minus 2 cos square x plus cos x, and we have plus 1 equals to 0. I always like to keep this as positive, so I'll write this as 2 cos square x multiplying by negative, right? Then we will factor. So we need product of minus 2 and sum of minus 1. So let's factor. We get 2 cos square x. So we could write this as minus 2 cos x plus cos x minus 1 equals to 0. Taking 2 cos x common gives us cos x minus 1 plus we already have cos x minus 1 here. So we get our factor cos x minus 1 times 2 cos x plus 1 equals to 0. So that should give us, we need to now find solution between 0 to pi by 2. So that gives us two possibilities. One is cos x equals to 1, correct? And the other one is cos x equals to minus half, correct? So this one here, when equated to 0, gives cos x equals to 1, and this one equated to 0 gives cos x equals to minus half. And we need to find solution between 0 to 2 pi. So if you look into your cosine graph, which is between 0 to 2 pi, is kind of like this, right? So the two solutions, one is right at 0 and at 2 pi, right? So we get two solutions, 2 pi and 0 for 1. And for minus half, we also get two solutions. Correct? So which are those two solutions? Minus half. We could use special triangle. 1 to square root 3. This is without calculators, correct? So this here, it is pi by 3. That gives you. And minus means that you are in quadrant 2 and 3, correct? So in quadrant 2 and 3, pi by 3 is your related acute angle, right? Pi by 3. So when that is the case, then the angle here is 2 pi by 3 and 4 pi by 3, correct? So those are the two angles. So one is 2 pi by 3 and the other one is 4 pi by 3, correct? So this is for half, and for 1 we already have x equals to 0 and 2 pi, correct? So we can now write down our answers, which is 0, 2 pi by 3, 4 pi by 3 and 2 pi as our solutions, correct? So I hope this is absolutely clear. Now let's move on and take the next question, which is 2 cosecant square x by 2 equals to 8, and this time it is from 0 to 4 pi. Okay, so we can write this as, let me rewrite, the cosecant square x by 2 equals to 8. So that means cosecant square x by 2 is equals to 8 over 2, which is 4. Now cosecant is 1 over sine. So I could write this as sine square x by 2 as 1 over 4, correct? So that means sine of x by 2 is equal to plus minus square root of 1 over 4, which is, let me write here, as plus minus 1 over 2, correct? Now another important thing to consider here is the domain. We are given the domain of x as between 0 to 4 pi, correct? So for x by 2, the domain will be, we have to divide both by 2, so we get 2 pi. You understand? So within 2 pi, we have to get all our solutions. Now let's look into the special triangle also, which is again pi by 3, pi by 6, 90, right? So pi by 6. Now 1 to square root 3. So we know that sine of pi by 6 is equal to half. Now we have 4 solutions. Plus minus means we are looking for pi by 6 in all these quadrants, correct? So that those are our solutions, correct? So as you can see here, we have x by 2 as equal to pi by 6, 5 pi by 6, correct? This is 6, this is 7 pi by 6, and this is 11 pi by 6, correct? So we have pi by 6, 5 pi by 6, 7 pi by 6, and 11 pi by 6. So x is equal to, multiply them by 2. So we get pi by 3, 5 pi by 3, 7 pi by 3, and 11 pi by 3. Do you see how we found the solution? Right? That's a very good question. You have to work on the domain, right, like we did, to get all possible solutions. Perfect. Now let's move on. We have question number 10 here now. Question number 10 is sine square 2x equals to sine 2x. Now we have to work in the domain pi by 2 to 3 pi by 2, right? So let's see this domain here. We have 2x. Okay, so we are given x in between pi by 2 and 3 pi by 2. So 2x will be multiplied by 2. We get pi to 3 pi. Correct? That is what our domain is. Okay, let's solve. So the equation here is sine square 2x equals to sine 2x. Let's bring them together. So we have sine square 2x minus sine 2x equals to 0. Now sine 2x is common. So we get sine 2x minus 1 equals to 0. So that gives you two possible solutions, right? So one factor here is sine 2x equals to 0. That gives, I will find the solutions. The other one here is that sine 2x equals to 1. Now we are looking into pi to 3 pi, right? So let's sketch the graph of sine function to get an idea. So we have, we'll sketch, okay. So in this graph, this is like 0. One full cycle is 2 pi, and this is 3 pi for us, correct? That is pi for us. So between pi to 3 pi, we are looking for zeros. So the zeros are these points. Do you see that? So for 0, we get 2x equals to pi, 2 pi, and 3 pi. So x is equals to pi by 2. This is pi, and this is 3 pi by 2. Do you see that part? Now, let us look into ones. So 1 is the maximum value, kind of this value, right? So these are the values for 1. So the only value between this is 2.5 pi, or you can say 2 pi by 2 plus half, right? So this is 3 pi. So we can say 1 pi by 2, 2 pi by 2, 3, 4, 5 pi by 2, right? So here sine 2x equals to 1 means 2x equals to 5 pi by 2, right? Or x is equals to 5 pi by 4. You get the idea. So that is how we are going to find the value of x from the second factor. So our answers are x equals to pi by 2, pi, 3 pi by 2, and 5 pi by 4, correct? So I hope this sketch here helps you to identify these solutions and also see that 2x should be between pi to whatever the angle is, between pi to 3 pi, right? So that is how you should actually try to find the answer. I would like you to pause the video, copy this question, and then look into my suggestions. Question number 11. We are given cosecant A is equals to 4 over 3, where A is between pi by 2 and pi, and we are given cos B as equal to 5 by 6, where B is between 3 pi by 2 and 2 pi, determine the exact value of sine A minus 2b. Now, when we say between pi by 2 and pi, that means this value is given to us in quadrant 2. On the other hand, b is given to us 3 pi by 2 to 2 pi in quadrant 4. Correct? Now, when we say cosecant A is 4 over 3, that means sine A is equal to 3 over 4. So let's make our triangle here in this quadrant where 3 is the opposite side and 4 is your hypotenuse. So in that case, what is this side going to be? It is going to be 4 square minus 3 square square root, right? 16 minus 9. 16 minus 9. So let's do 16 minus 9 square root. And that gives you square root 7. So this side is square root of 7. The other, in this particular case, 5 by 6 will have 5 as your adjacent side, 6 as hypotenuse. So this side is 36 minus 5 square is 25 square root, which is square root of 11. Correct? Now sine A is 3 over 4. What is sine B equals to? Sine B has to be negative because we are in quadrant 4. So it is be negative square root 11 over 6. What about cos A? Cos A will be negative square root 7 over 4. Correct? So these are your values to work with. Now, let's find the expression, which is sine A minus 2b. So when I say we have to work for sine A minus 2b, that means sine A cos 2b minus cos A sine 2b. Now we can write these double angles in single angle, right? Sine A. Now cos 2b could be written as cos square A minus sine square A, right? So we could write this as cos square A minus sine square A. We could also, cos square B minus sine square B. So that is one way of writing. Okay, so let's write this. Cos 2b as cos square B minus sine square B. Okay, here we have cos A. Sine 2b is 2 times sine B cos B. Perfect. So let's now substitute the values. Sine A is 3 over 4. Cos square B. So this value given to us 25 over 36 minus sine square B. This is negative but becomes positive when you square it, right? So it becomes 11 over 36 minus cos A, which is minus square root 7 over 4 times 2 times sine B, which is again minus, so we'll write minus square root 11 over 6 times cos B, which is 5 over 6. 5 over 6, correct? So these are the values to work with. So we could take this on the right side and simplify this a bit. So we have 3 over 4 here. Within bracket, 36 is common. 25 minus 11 is 14. So we get 14 over 36. Okay. There are 3 negatives, so it remains negative. This could be simplified. We could divide this by 2, right? So 7 times 11 is 77, and then we have 5. So we have 5 square root of 77 over 6 times 6, 36 times 2, 72. 72. Correct? So this is what we get. Okay, so now we could simplify this further. 3 goes 12 times. Okay. And that is 7 and 2. So we have here 7 over 24 minus 5 square root 77 over 72. So 72 is a common factor 3 times. So we get 21 minus 5 square root 77 as our answer, correct? So this particular expression, which is sine A minus 2b, should be equal to 21 minus 5 square root 77 over 72. Perfect. So that is how you could solve this particular question, right? Question number 12. Let's prove cos 4x equals to 8 cos to the power of 4x minus 8 cos square x plus 1. So let's begin with cos 4x. Now we'll use actually double angle formula, right? So cos 4x can be written as 2 times cos square 2x minus 1, correct? So the formula which we've used here is, let me write in this term, like cos 2a is equal to 2 cos square a minus 1. So that's the formula which we have applied. Now we can again apply the same formula for cos 2x, right? So we have 2 times, so here cos 2x can be written as 2 cos square a, which is x, x minus 1, right? Whole square, and then we have minus 1. Does it make sense to you? So what we did was, we substituted for cos 2x, 2 cos square x minus 1 whole square, that square, minus 1. Perfect. Now let's expand this, right? So when you expand this, in that case you get 2 times square of this gives you 4 cos to the power of 4x minus 2ab, that means 4 cos square x plus 1 minus 1. Let's open the bracket now. So 4 times 2 is 8 cos to the power of 4x minus 8 cos square x plus 2 minus 1. And that gives you 8 cos to the power of 4x minus 8 cos square x plus 1. Correct? So you get the right hand side as expected. So I hope that is absolutely clear. Right? We have one more question to go. Okay, here is question number 13, and this is definitely the last question to do. So I hope you're finding it interesting and useful. These are pretty good questions for your test. So at this time we need to prove that left side equals to right side, and left side is sine 2x over 1 plus cos 2x times cos x over 1 plus cos x. We need to show that this is equal to tan 2x. So we'll begin with the left side. Okay. Now, since this is 1 plus cos 2x, again the formula being used will be cos 2x equals to 2 cos square x minus 1, correct? Okay. So we could write this as, so sine 2x, let me write this as 2 sine x cos x. And the denominator, I'll write 1 plus 2 cos square x minus 1 times, we have cos x here, over 1 plus cos x. Okay. So plus and minus 1 cancel. So what we get here is 2 sine x cos x, rather square x, when you multiply this, right, cos square x, over, here we have 2 cos square x times 1 plus cos x. Correct? So cos square x and cos square x cancels, 2 and 2 cancel. So we are left with sine x divided by 1 plus cos x. Now, how do we get tan x by 2 from here? Okay, so what we can do, again write sine x as 2 sine x by 2 over cos x by 2. Correct? And as we had cos 2x, we have 1 plus cos x. I could actually write this as 1 plus cos 2x equals to 2 cos square x. Do you see that?
So 1 plus cos x can be written directly as 2 times cos square x by 2, right? So that is what I'm going to do. So I'm going to use the same formula which I used earlier in a different way after rearranging, right? So you understand this. And as you can see, we can cancel these terms. So what are we left with? We are left with sine x by 2 over cos x by 2, which is nothing but tan x by 2, the right side. Do you see that? So in this particular example, we have used the double angle formula of cosine twice to get our result. That brings us to the end finally. I hope you find this series very interesting and useful. Feel free to share it with your friends, and I hope that helps. Thanks for watching and all the best.